So we are going to look at chapter 4 and 5 problems. Okay. So chapter 4 is basically, probability problems. Okay. So remember a couple of points. Um, if you want to do a probability experiment, we need to get a sample space. Okay. The sample space we denote by a big S. So the sample space means that is nothing but a set of um, all possible outcomes, right? Okay. Suppose if you want to find the probability of any event E, this is basically nothing but number of possible, outcomes from that particular event. Then you have to divide by the number of all the possibilities from your sample space. Okay. So this is the formula basically we use for the probability problem. Okay, E could be any event. So now in this first problem, our event is what getting a number 7 when you roll a die. So that is our event E here, getting a number 7, right? So you could use this formula to find the probabilities. Remember, first of all, you need to know the sample space for the given problem. Okay. So when you roll a die single time, what are the possible numbers we may get? We may get any number from 1 to 6, right? So that means that is going to be our sample space, all the possibilities, right? So now the question is, what is the probability of getting number 7, right? So the probability of getting 7 is what? I don't see any number 7, right, in my sample space. So if you do not see anything from your sample space, the probability of always going to be 0. Okay. So in another word, the probability of any impossible event is always going to be 0. If you know the event for sure going to happen, then those kind of certain events is called the probability of certain event is always 1. Okay. So keep in mind these two things. So this is kind of impossible event because I don't get 7 here for sure. Therefore, it is 0. So now the probability of getting an odd number, right? So remember, if you want to get the odd number, here ask yourself, what are the possible odd numbers you may get? You may get 1, 3, or 5, right? So there are 3 possible, outcomes you may get for the given problem. That is 3, right? I'm using this formula, the number of outcomes from your particular event. Getting odd number is my event now. That is 3 possibilities out of 6, right? Because your sample space has 6 possibilities. So always you have to put that down. So answer is 3 over 6. So when you write down the probability answers, make sure that you are writing the simplified version. So this is half, or you could write just zero point 0.5, right? So your probability of any event answer always going to be between 0 to 1, inclusively 0 and 1 possible. So your probability answer, cannot exceed this range. Okay, so your probability answer is always should be less than or equals to 1 and bigger than or equals to 0. Keep in mind that point. So if you get any probability answer bigger than 1, that means you are making somewhere mistake. It is not possible. Okay. Now in this problem number 2, now we are rolling 2 dice, right? Let's say who is telling how many outcomes we will get in a sample space when you draw 2 dice. 1 1, 1 2, 1 3, and all the way up to 6,6. So if you look at all the possible outcomes here, you will get 36 outcomes. Okay. So the probability of getting some 5 from both dice, right? So that means you have to look for getting some 5. What are the possible numbers you may get? You may get 1 from first die and 4 from the second one, or you may have 4 and 1, or 2, 3, or 3, 2. These are the possible, outcomes you may get to get, some 5, right? So if we count 1, 2, 3, 4, there are 4 outcomes out of 36, right? My sample space has now 36 outcomes. Therefore, answer is 4 out of 36. So that is 1 over 9, right? So for part B, you have now 2 events. They're asking you to find the probability of some 9 or 10, okay? 9 or 10. So you could think of this one as the event A, this one is event B, getting number 10 is event B, getting some 9 is, event A. So you could use the probability of A or B formula. It is simply probability of A plus the probability of B. Okay, remember here A and B getting some 9 and getting some 10 are going to be mutually exclusive events, right? What does it mean by that? That means these two events cannot happen at the same time, right? That is obvious, right? You will get either one. Either you will get some 9 or some 10. So if you have such an event, that is mutually exclusive events. Therefore, you could use this formula. Please look at your class note. For mutually exclusive event, probability of A or B is simply probability of A plus probability of B. So if you apply that formula here, getting the probability of some 9 or 10 is simply probability of getting some 9 plus the probability of getting some 10. Now you need to find out these two separately and add them. Okay. So the probability of getting some is how many numbers you will get. To get some 9, you may have 4, 5, 5, 4, 3, 6, and 6, 3, right? These are the possibilities you may have to get some 9. To get some 10, you have 5, 5, 4, 6, and 6, 4. Okay. So altogether, if you put here, answer is going to be the probability of getting some 9, 1, 2, 3, 4 out of 36 sample space plus some 10 is 3 out of 36. Okay, so now if you simplify this, that is going to be 7 over 36, right? Then part C, getting doubles. That means probability of getting doubles, you are getting same numbers, right? So that is how many possibilities are there. You may get 1 1 from both dice, or 2 2, 3 3, 4 4, sorry, 5 5, and the 6 6. So these are the possible doubles you may get. So 1 2 3 4 5 6. There are 6 possibilities out of 36. That is going to be 1 over 6, right? Okay, to do number 3, a card is drawn from a deck of cards. So the sample space here is going to be all the 52 cards from, the card pack, right? So all 52 cards are going to be our sample space, right? Remember, there are 4 suits in the card pack. So you may have spades. There are 13 of them. Then clubs, again 13. And cards, 13 cards. And then diamonds, again 13. First two are black. First two suits, right? We call these as suits. And the second two are red. Okay. So each suit has 13 different cards, right? So that is you know a k king queen jack, and number 10 9 8 7 6 5 4 3 2, right? 1 2 3 4 5 6 7 8 9 10 11 12 13. So these are the the values of the cards you have for each suit. So there are 13 cards from each suit. There are 4 suits. Therefore, 13 times 4 will be 52 cards in total. Now, the first probability of is finding the probability. You are drawing only single card, remember. You are drawing only one card, okay? So the probability of getting 6 at the same time that card should be spade. You will see only one such a card in spade suite. Therefore, the answer is probability of getting 6 and spade is simply 1 out of 52, right? Okay, 1 out of 52. So the second problem is now finding the probability of getting a black king. Remember, there are two suits which are black, spades and club. So we may get two kings from those two, right? Therefore, there are two possible kings out of, again, 52. So if you simplify, this is 1 over 26. Okay. Now here, you are choosing a card, one card, remember, that should be red color at the same time 7, right? So here also, you may have two, such a card because hearts and diamond has red color. Each of them has, you know, number 7. Therefore, the probability of getting red at the same time, which is number 7, is 2 over 52. That is 1 over 26. But if you look at the last one, you see that is or. Therefore, the probability of getting diamond or heart is going to be what? Remember, now you have two events. You could think of A and B events. You are choosing only one card. There is no way, to have both of them at the same time because you are choosing only one card. So therefore, it is impossible to have these two events at the same time. Therefore, these two are mutually exclusive events. Okay, please go and refer our class note. These two events are mutually exclusive events. Events cannot happen at the same time. If two events are mutually exclusive, then probability of A or B is simply probability of A plus probability of B, right? Okay, so that means probability of getting diamond, that is my event A, plus the second one is probability of getting hearts. So what is the chance of getting diamond? Remember, there are 13 of them out of 52, plus hearts also, there are 13 out of 52. So if you simplify, this is going to be 26 over 52, that is simply half. So there's half chance, that you may take the card which is either diamond or heart. Okay, that is the answer. For number 4, you are given a table. So there are 100 possible cars brands are given here. So what is the chance of having the next car means, so you are looking for the probability based on this table. So what is the chance of having a Ford? So you have to check how many Fords are there. So in total, find the total, right? So just add them. We know that should be 100, right? So you could think of this is the number of outcomes from your sample space, all the possible numbers, right? So the probability of getting Ford is simply, how many Fords are there? There are 23 out of 100. So if you want, you could write in decimal. So that is 0.23. Okay. The second one, you are choosing the one which is not a Toyota, not Toyota. That means you have to add all the possibilities. So with except Toyota, that is 23 plus 18, next 17 and 17. Then all possibilities is 100. So if you simplify, so you should get this as 75, right? Over 100, so which is 0.75. Okay. Or you could use the complement event technique. So please go and check the notes. Okay, refer our notes, please. The probability of any event E is simply 1 minus the probability of complement of that event. The complement event we write as EC. C stands for complement, right? The complement means you are excluding that event, right? You are excluding that event. So simply the negation of that event, you could think of that. So if my event is, not Toyota, the complement of that event is simply Toyota. Okay. So the probability of finding not Toyota is equals to 1 minus the probability of finding the Toyota probability. So this is another way. So the probability of not a Toyota is simply, if you use this formula, that is 1 minus the probability of getting Toyota. Now this will be equals to simply you find the probability of getting Toyota. So if you look at that, that is 25, okay, out of 100 cars. So if you simplify this, that should be 0.75. Same answer you are getting in different way, right? So you could choose either way to do this problem, either method, okay? Now here again, you see or, so you could think of the probability of Chrysler or GMC. Remember, we are looking for only one car, right? So you cannot have both at the same time. Therefore, again, this is mutually exclusive event. So the probability of finding Chrysler or GMC is simply the probability of finding Chrysler plus the probability of finding GMC, right? So now this is simply Chrysler is going to be 17 out of 100 plus GMC is going to be 18 out of 100. Okay, so if you simplify that, that is going to be 35 out of 100, so which is 0.35. Okay, that is the probability of the part C. The next one, the probability of guessing next car, which is Rolls Royce. I don't find such a car here, therefore the chance of having this one is simply impossible event, which is 0. Okay. So once you have table, it's going to be always easier, right? So because you know the total, that is going to be a sample space. Then after that, look for the particular given event. Simply put that number and make the fraction, and you will find the answer. Okay, let's look at number 5. For number 5, I'm going to make a Venn diagram. Venn diagram will make easy to do this kind of problems, right? For number 5, so I'm using a Venn diagram. Sorry, spelling is not correct, right? So I'm drawing a Venn diagram here. This is going to be my entire class, or you could think of sample space, right? So there are 100 students in the class, therefore my sample space should have 100 possibilities, right? So you could think of NS as 100. Now there You see here, there are two events here. One is getting statistics and subject, another one is calculus subject. So only two possibilities. So I'm just drawing two circles. Okay. So I'm taking this is say S and say this is C. Here S stands for getting students statistics, and C stands for a calculus. Okay. So if you read the problem carefully, 75 takes statistics, right? So that means there are 75 students, they take statistics. They may have all, oh, I'm writing in wrong place. So 75 should be here. They say that 75 take statistics, right? So there are 75 students take statistics. They may have only taken that statistics, or they may have both calculus and statistics. Therefore, I am writing that number on the circle of S. You look at again here, 21 take a calculus, so I'm putting 21 here on the circle of calculus. 13 take both, therefore 13 should be in overlap. Those who are taking, both subjects. If this is 13, we could subtract 13 from 75 to find out how much students they are taking only, how many students taking only statistics. So 75 subtract 13 is going to be 62, right? And similarly, if you subtract 13 from 21, it's going to be the number of students those take only calculus, right? Like that, you had to complete inside. So if you add inside all three numbers, 62 plus 3 is 75, 75 plus 8 is 83. But remember, in the class we have to have 100 students. So if you subtract 83 from 100, the remaining are going to be outside of these two subjects, right? So like that, first complete, the Venn diagram. Now the problems are going to be very easy once you have a diagram. So what is my answer? So let's write down our answer. Choosing one student, that student should be, taking statistics, right? Given that he or she takes calculus. So if you write that entire statement in symbolic way, this is nothing but the probability of finding statistics given that that student takes calculus. Remember, this is conditional probability. Please check your notes. Please refer your class notes. Okay, this problem coming under conditional probability. Okay, so you are finding a probability, but based on some conditions. So if you look at your notes, the probability of conditional event S, right, conditional on C, which is given by the probability of S and the probability of event C over probability of event C. Okay, this formula is there in your class note. Okay, so S stands for statistics, C stands for calculus. If this is the case, then let us find out, the first piece of probability. What is the probability of getting statistics in calculus? So if you look at that, that is nothing but this region, right? Overlap region. There are 13 out of 100 students in the class. Therefore, the probability of, S and C is 13 over 100. That one I'm going to divide by the probability of getting calculus. So that means you have to look for the calculus subject. That is simply C circle. Remember, you have to include 13 as well. Therefore, the number of possibilities under C is 21 out of 100. Okay. So that is, if you simplify, it's going to be 13 over 21. This is approximately 0.619. Okay. That is my first answer. So the second one, find the probability that students take calculus given that statistics. So they are asking in another way around. So the probability of finding calculus given that the students take statistics, So if you think of this again, the conditional probability formula says that C and S over P of S, right? So again, the probability of students taking calculus and statistics is again 13 over 100. Numerator doesn't change like earlier, but the denominator now changes. The probability of statistics is simply, the statistics circle, which is 75 out of 100 students. That is 13 over 75. Okay, so that is approximately 0.1733. Okay, let's do part C. Find the probability that the students take stats or calculus. So the probability of stats or calculus. Okay. Hmm. Now these two are not mutually exclusive, right? These two events now can happen at the same time. Students may take both subjects at the same time, right? Therefore, this is not mutually exclusive. If it is not mutually exclusive, please check your notes. The probability of two events SOC, right? It is the probability of event S plus the probability of event C. Then you need to subtract the probability of overlap region S and C. For mutually exclusive, this part will not be there. That is why, in the previous problem, we had only these two. But now these two are not mutually exclusive. Therefore, you have the overlap, event as well. So if you use this formula, then what is my answer? Okay, the probability of statistics, we know that there are 75 students taking statistics out of 100. What is the probability of calculus? There are 21 students taking calculus out of 100. Now the overlap region, right? There are 13 taking both. So it's going to be 13 over 100 then. So if you simplify this, that is going to be 83, okay, over 100. So that is 0.83. Okay. So you could think of OR means like a union set notation. So you could think of S union C means everything, belongs to these two circles. That is 62 plus 13 plus 8, which is 83. That's why we got this number. Okay. So answer is 0.83. That is part C. The last part. Okay. So let me do last part somewhere here. What is the probability that the randomly selected student takes neither statistics nor calculus? There's a hint. The complement event to take neither statistics nor calculus is simply take statistics or calculus. So you could use that complement event formula I just gave. So use this formula, okay? So these two events are, the complement event of each other, right? So I'm using this formula now. What was the question? Question is finding the probability that the students take neither statistics nor calculus. So the question is finding the probability of neither statistics nor calculus. So if you think of this as the event E, right? The complement event they are telling the under the hint, which is statistics or calculus. So this is simply 1 minus P of statistics or calculus. Simply I am using that, you could think of this as the complement event of neither. Okay. So now, if this is the case, this is going to be P1 minus P of SOC, statistics or calculus. That answer already we got from part C, right? Part C problem was exactly finding SOC. So we need the answer that the probability of SOC we got 0.83. That means for this piece answer is 0.83. Okay. Subtract this, so it's going to be 0.17. In another word, they are asking the students, they never take both subjects, that is simply outside of these two circles, which is 17, right? Over 100. So you will get the same answer, right? 17 over 100 is 0.17. Okay, okay. So look at number 6, problem number 6. Now, to do number 6, if you want, you could make a table. So if you have table, problem will be easier. I'm going to make a table. Okay. So I need, oh, this is junior, this is senior, and this is the total. That side I could think of like a male, female, right? Then here I'm taking total. So if you read the problem, there are 12 juniors and 15 seniors. 7 of the juniors are male, so 7 are male, right? Mm. And 7 juniors are male, but they are telling in total there are 12, therefore remaining should be female, 5. And the 15 seniors, right? 5 of the seniors are female, so it's going to be here 5, right? And here should be 10. So here 17 males in total, 10 females, right? So if we add all 12 junior, 15 senior, 27 in total. So like that, so you could make a table. So once you have table, it's going to be very easy. Remember the question. They are selecting only one, right? Going to the class and selecting one student. We don't know who is, maybe male, maybe female, maybe junior male, maybe junior female. We don't know, right? So the first part is finding the probability of selected students, sorry, right? That student is a senior or female, right? So you could think of this is event A, this is event B. Ask yourself, is that possible to have these two at the same time? Yes, it is possible. The selected student may be senior and female. It is possible. Therefore, this is not mutually exclusive. So you have to use the probability of A or B, probability of A plus, probability of B, subtract the overlap. Okay. So if you use that formula, this is simply A means the probability of senior. Okay. So tell me now, if you select one student, what is the probability of being a senior student? Of course, you have to look for the possible values of senior. Under the senior, there are 15, right? The possibility of choosing a senior is 15 out of 27. There are 27 in total in the class. Then what is the probability of B? B is female, choosing a female student. So if you have to look at the total possibility of female student, that is 10 out of 27. Then subtract the overlap event. Selecting student should be, a senior at the same time female. So senior and female, there are 5 out of 27. So if you simplify this would be how much? 20 over 27, right? So approximately 0.7407. Okay. Make sure that you understand this mutually exclusive and not exclusive event. For the second part, what is the chance of having a junior or senior? So if you are really smart, you could write the answer within a step. Remember, we are going inside the class and choosing one student. Of course, 100% we are sure that that student should be either junior or senior, right? We have only two possibilities. So choosing one should be either one, right? That means this event is going to be happen for sure. Therefore, answer is one always. I could write within a word, within a step. But if you want to get in detail, right? So you could think of like again A and B events. Now these two events are mutually exclusive, right? Choosing one student, you know, either maybe junior or senior cannot have, both at the same time. Therefore, this is mutually exclusive, right? So choosing a junior or a senior is simply the probability of junior plus the probability of senior, right? So what is the chance of having junior? So simply take the total of junior, which is 12 out of 27, plus what was the senior number? Senior is 15 out of 27. So that is 27 over 27, which is 1. So this is another way to do this problem, right? Either way. Number 7. In an election, 47 of eligible voters did not vote. So we know that the probability of person did not vote, the chance of not voting is 47 percentage, right? 47 percentage means that is if you divide by 100, which is 0.47, right? So we know now the chance of the person did not vote, which is 0.47. Keep in mind that. The question is now, we are choosing three different people, right? So you could think of all three are independent people, right? Now we are going and checking the probability of, chance of none of them voted in the election. There are three, so you could think of all three as, independent events. So go and check your notes under independent events, okay? So if two events are independent, right, what does mean by that? The probability of one will not affect the probability of another. That is called the independent events. If two events are independent, then the probability of A and B is simply the product of the probability of first event and the second one. Okay, so this formula is correct only those two are independent events, A and B. Now here there are three people, so you could think of three events. All three are independent, right? Voting one guy will not affect another one's, output. Therefore, all three, you could think of like three independent events. Therefore, the probability of finding three is simply the product of finding the probability of three. Therefore, the probability of none of them voted out of three, right? There are three people. That is simply what is meant by this. This means the probability of first guy did not vote and the second one also did not vote and the third guy also did not vote. So this is the meaning, right? So you could think of now there are three events in this problem. So you could think of first guy did not vote. This is event A, this is event B, and this is event C. So the probability of A and B and C is simply the product of those three, right? Therefore, this is simply the probability of first guy did not vote times the probability of second guy did not vote. Then I don't have space here, so let me write down here. The probability of a third one did not. So this is the meaning, right? But now we know the chance of each one did not vote is 0.47. Therefore, that is 0.47 times 0.47 and times 0.47. Okay? So in another word, this is 0.47 cube. That is, if you simplify, you should get 0.1038. Chance of all three did not vote is nearly, 11 percentage, right? Just over 10 percentage, right? So that is part A. To do part B, you are choosing three guys again. What is the probability of at least one of them, one of those three, voted? Again, I'm going to use a complement event formula. The probability of any event is 1 minus the probability of event's complement, right? So if this is my event E, I could use my complement formula, that is 1 minus P of E complement. Okay. If my event E is at least 1, remember the complement event of at least 1 is none of them. Okay. So the complement of at least 1 is none of them, right? That means what? That means the probability of at least one of them water is equals to 1 minus probability of none of them water. Okay. That means this is the 1 minus the probability of none of them waters. But to get this piece of probability, we already know the probability of none of them water from the first part. Exactly, we were finding the probability of none of them water. We got that answer, right? Simply you could use that answer here. So this is the easiest way to do this problem using the complement event formula. Okay, so if you subtract, you should get which is 0.8962, right? Nearly 90 percentage. Yeah, that makes sense, right? If you choose randomly 3 people, for sure one of them may put the vote, right? More chance, right? Therefore, this answer makes sense. So that was problem number 7.
No question, sir.
Is that understandable? You
Yes.
understand?
Yes.
Now we are going to use that counting numbers, the combinations and the permutations, those things to find out the remaining problems. Okay, number 8. Oh, just a minute. No. This also the probability problem, number 8. 2 cards are selected from 52 card deck without replacement. Find these probabilities. Okay, so I could draw a tree diagram to do this problem. Okay, so I'm taking first 2 branches as my first drawing. That means I'm looking for either kings or none. None king, right? No king. For my second, this is my second drawing. I may choose king, none king. Remember, when you choose first time, there are 52 cards. So what is the chance of getting a kings? Remember, there are 4 suits. Each suit has 1 king. Therefore, it is a 4 out of 52. Remaining 48 cards are non-king, right? Now, the problem was without replacement, right? You are taking 1 card and you are not putting back. Sorry. You are not putting back. Therefore, the second chance, if you choose king for the second time, remember you assume that first time you already have taken king. Therefore, here 1 is less, right? Now you have for the second chance, you have only 51 cards because you are not replaced. So choosing second time king is 3 over 51. So remaining all 48 should be non-king. This branch says you have to assume that you're choosing first time is non-king. Then what is the probability of second time also non-king? Now you have 1 less than the earlier. So like that, finish. Okay. So now the question is what? You are choosing 2 cards, finding both king, king. So that means choosing king, king both. So the first time is 4 over 52. Then times we have to multiply. Okay. Second one is 3 over 51. Right. So this is going to be very close to 0.0045. Okay, if you have any questions, please let me know. So you should know how the number I have put here because of the, without replacement, you are not replacing, you are not putting back to check the second card. That is why 1 less, right? Yeah. Okay. The second one, what is the chance of getting both cards are different suits? That means what? That means suppose if the first card is spade, you cannot have spade in second. You have to have some other. So what is the chance of having such a cards? There are plenty of chances. But I could use now again the complement event. The complement of different suit is going to be same suit. Okay. The probability of finding different suit is going to be 1 minus the probability of finding the same suit. Okay. How are we going to find that probability? So that is the probability of same suits means what? That means both maybe spades or both maybe clubs, we don't know, or maybe both hearts, don't know, or maybe both diamonds, right? So these are the possibilities, right? So you may have any of these four chances, right? Remember, having each and every event has equal chance, right? Having both spades and both clubs and both hearts and both diamond all have same equal chances. Okay, so that is why if you want to find this probability, this is equivalent to finding 4 times of the probability of simply one of them. Okay, or you could use mutually exclusive formula, right? Find it separately. Since you have all same probability, simply you could multiply with one of them, right? With one of them, you could choose any of these four here. I'm choosing the first one, right? So what is the chance of having both spades? You have to think a little bit. What is the chance of having first time spades? When you choose the first card from the card pack, how many spades are there? There are 13 of them, right? Out of 52. But for the second time, you are not replacing, remember? You have only 20 spades out of 51. So this much of probability will have for each event. So therefore, if you add all four, that is equivalent to multiply by 4, right? So that is, if you simplify this answer, you will get, just a minute. So you have to get, please check this answer, 0.7647. Okay, basically, we write 4 decimal places for probability, okay? If you are not asking, if you are not asked to, write down any particular decimal places, remember the default is 4 decimal places, right? So this is problem number 8. Now look at number 9. Okay, these are all about, combinations and permutations. In a board of director composed of 8 people, in how many ways can one chief executive and the office chief executive officer and one director and one treasurer be selected? Remember, ranks are in order, therefore order is matter for this problem, right? Order is important. Please go and check your note. If order is important, the number of ways you could perform this is simply you have to use NPR formula, right? P stands for permutation. What does mean by NPR? NPR means the number of ways you could choose R objects from N objects if you put in order, because order is important here. That is called as NPR. Please go and check your note, please. Otherwise, you can't understand, okay? Number of ways you could arrange R objects from N objects is NPR, this much number of ways. This is just a number. If you're plugging this all into calculator, you will get simply number, right? Remember, N is basically should be bigger than or equals to R. R is the smaller guy. So you are given N objects first. So you are choosing R among them. You may have equal. You may have selected all of them, right, in order. So it is possible to have N and R equal, but R cannot exceed N, right? So in this problem, the given number of people is 8. So you are choosing 3, from them, but you are putting in order because, the title is matter here. Therefore, the number of ways you could arrange is simply 8 8P3. Okay, 8P3. How do you find this answer? Okay, you could use the calculator to find 8P3, right? Let me show. Take your calculator. First, type the number 8. Then you need to get the permutation formula, right? Permutation is there under math. Go to math, then choose number 4 option PRB, PRB. Then choose the second one. You see here NPR. Then enter. Then type the second number 3. Then enter. There are 336 ways you could choose, 3 different titles from those 8 people. Okay, so this is the answer. So if order is important, use the permutation formula. If order is not important, then use combinations formula, NCR. The number 10 is again the conditional probability problem. A small college, the probability that a student takes physics and sociology is 0.18. The probability of choosing physics and sociology is given, which is 0.18. And the probability that the student takes sociology is 0.72. The probability of sociology is 0.72. These two are given in the problem, right? The question is now, find the probability that the chosen student is taking physics, given that we use conditional probability, that student taking sociology. So they're asking basically, you could think of this is event A and this is event B. The conditional formula, that is P of physics and sociology. I'm using conditional formula over the probability of sociology, right? So use the conditional probability. So, but we know these two answers. The probability of physics and sociology is 0.18 over the probability of sociology is 0.72, right? So now this is 0.25. Okay. So sorry, there is there. So if you make mistake, if you flip this fraction wrongly, you will get the answer bigger than 1. Remember I told you at the beginning, probability answer cannot exceed 1. That way you could think of your answer whether you have put the numbers correct place. Okay. So use the conditional probability formula whenever you see given some events. Okay. That is number 10. Again, number 11, in how many different ways can a committee of 4 people be selected from a pool of 10 people? Remember, order is not important here. You could choose any 4 in any order. They did not mention anything about the order. Therefore, order is not important in this problem. Order is not important. Okay. Therefore, I'm going to use NCR formula, combination formula. Remember, you are given in total, there are 10. You need to choose 4 at a time. Therefore, the number of ways you could choose is 10, choose 4. Okay. How do you find that one? You could use either formula for NCR, look at the note, or simply type this into calculator. Using calculator is always easier, right? So go to your calculator. First type 10, then go to math, go to number 4, PRB, then choose NCR number 3. Okay, then type 4. So 10C4 is 210. So there are 210 ways you could choose, or 4 people from 10 without considering an order. Number 12. Again, if you look at number 12, now the things are different. You need to perform 2 tasks now. First choosing women and after that choosing men, right? So if you have more than 1 task, simply you need to multiply those tasks, right? So in this problem, remember there are two tasks. Task number one, you need to multiply with task number two. Okay, what is task number one? Choosing women. So you have to treat these two as two different problems. How many ways can a jury of 6 women, there are 6 women, right? And 6 men can be selected from 9 women. So that's 9 in total. You have to choose 6 at a time. Therefore, task number one, you could think of for choosing women. And task number two is choosing men. Right? How many ways you could choose women? Remember, there are 9 of them. You could choose 6 at a time. Order is not important. Therefore, 9, C, 6. Right? Now you need to multiply with the task 2. Task 2 is choosing men. Again, we need to choose 6 men out of 12 men. Therefore, out of 12, you need to choose 6. So take your calculator and plug in these two. Okay, so 9 choose 6. I need to type 9 choose 6. And I'm going to multiply with what? With 12 choose 6. 12. Again, go to math. And choose 6. Okay, simply multiply them out and you should get this answer. Oops, my answer is different. I typed wrongly, right? Oh, I need to put the parentheses, I believe. I think I need to put the parentheses. So here you first type 9 choose 6. 9 choose 6 should be 36. Then type 12 choose 6 should be 924. Then multiply these two. It should give you 33264. So correct me if my answer is wrong, okay? Or you could type all together, but here I did not put the parentheses. So you need to put the parentheses. Let me check one more time. So 9 choose 6. Then I'm multiplying this answer with 12 choose 6. Could you tell me which answer is correct? What's the mistake? Let me check. What is 9 choose 6? Oh, I see. So this answer is not correct. This should be 84, right? You need to check your solutions in solution manual. Please change that into 84. I mean, this answer is not correct. Okay, so let me double check. What is 12C6? 924. That is fine. So my answer is now 84 times 924. Yeah, 76, 77, 616, right? That is the answer. Please change the answer into my solution. So correct that mistake. Okay. What else? Number 13. A bag contains 5 red balls and 7 white balls. If you randomly grab and draw 4 balls, find the probability that you get 2 red balls and 2 white balls. So first of all, look at the problem here. There are 7 white balls and 5 red balls, right? The question is, we are choosing 4 randomly. We don't know what kind of balls you are getting. All you are simply grabbing 4 balls. We don't know. The question is, find the probability that you get 2 red balls and 2 white balls. Remember, there are so many possibilities to choose 4 balls, right? You may choose all 4 whites, you may choose all 4 reds, or you may choose 3 white, 1 red. There are plenty of possibilities. But they're asking, among those possibilities, what is the probability of having 2 red and 2 whites? Okay. So you could think of this as event E, getting 2 reds and 2 whites. So if you use the formula, remember, this is simply the number of possibilities from your given event divided by number of possibilities from your sample space. So you could think of like, what is sample space here? What are the all possibilities? Right? Remember, In total, you are given 12 balls, right? So you are choosing 4 of them, okay? So in how many ways you could perform this experiment or this trial? You are choosing 4 balls from 12 balls. So order is not important. So there are how many ways you could choose? You could choose 12 C4 ways, right? So this is the total possibilities you may have. So this is nothing but, this answer is nothing but all the possibilities from your sample space. So you ask yourself, in how many different ways you could choose 4 balls from 12? There are 12 C4 ways. That is going to be my all the possibilities. Among these 12 choose 4 ways, how many ways you could perform the particular given event? My given event is now choosing 2 reds and 2 whites, right? So this one you could, now I need to find out any, right? The number of ways you could perform, what event is choosing 2 reds and 2 whites. So this is nothing but, like earlier, you could think of 2 tasks, right? Task 1 times task 2. What was your task 1? Choosing 2 reds. Task 2 is choosing 2 whites. Okay, now ask yourself, how many ways you could choose 2 reds? Remember, there are 5 reds in total. So therefore, you could choose 5 C2 ways, right? Choosing reds. In similar way, how many ways you have to choose 2 whites from 7 whites? Therefore, that is 7 choose 2 ways. I am not considering about order here. That is why I am using combination formulas all the time. Right. So if you multiply these two together, you will get, the numerator piece of your probability. That is simply N of E. That's it. Simply plugging these two numbers into your formula, you will get the answer. So the probability of choosing 2 reds and 2 whites is simply 5C2 times 7 choose 2 over 12 choose 4, right? So if you want, you could find one by one or three by using calculator. 5C2 should be 10, right? Please look at the answer. And the 7 choose 2 should be 7 times 6 over 2, which is 21. Over 12 choose 4 should be 495. Please check whether I'm getting correct. That's it. Simply now simplify this. This is approximately 0.4242. So this question is kind of tricky problem, but still understandable, okay? This all about chapter 4. Do you have any questions? I think last two coming from chapter 5. Am I right? These two, 5.1 and 5.2 is maybe finding probabilities with, okay. Okay, now we are in chapter 5. You are given a table, distribution table. We don't know whether this is probability distribution or not, right? How do you check whether the given distribution table is probability distribution? There are two conditions you have to always check, right? If you want to check the given table is a probability distribution table, the probability of each cell should be between 0 to 1 inclusively. Okay, 0 and 1 also possible. The second condition is, if you add all the possible, probabilities, we use this notation. We call this as sigma, uppercase sigma in Greek letter. That means you are summing up all the possible px values, probability values. This answer should be exactly 1. If these two conditions are satisfied, then we say that the given, distribution table is probability distribution. So you have to think, basically you have to check these two, right? First condition is satisfied easily. You look at the each px answers for given x. These all your probability answers, okay? For sure, we know that these three are going to be now between 0 to 1, right? Or you could conform, plugging into calculator. One half is 0.5 less than 1. This is 0.33. This is 0.16, something like that. All three numbers are now between 0 to 1. Therefore, first condition is satisfied. Okay. So you had to write clearly. So for this problem number 14, you had to write answer like this. First condition. Okay. All the probabilities, Px is now less than or equals to between 0 to 1, right? Yeah, because all the numbers are there. This is correct. Second one, you have to now check the summation of Px, right? That means what? Add all possible Px. Remember, you have now three possible Px values. There are three. So have 1, 3 and 1, 6, right? So add all three numbers, make sure that you are getting 1. You should get exactly 1, right? Will you get 1? If you want, you could use LCM. So common denominator is now, 6, right? So you could make 6 here. So that is, if you make 6 as a common denominator, this will be 3 plus 2 plus 1. So that is 6 over 6, which is 1. Yes, exactly, I'm getting 1. So both conditions are satisfied. Therefore, the given distribution is probability. Therefore, the given distribution is yes, probability distribution. That is there. The second one, you are given the probability distribution. You don't need to check. They are telling already that the given table is probability distribution. But anyway, you could check whether all the numbers added up to 1. So simply plugging all, 5 numbers and check whether they are getting, you are getting 1. You should get 1 because they are telling that it is a probability distribution table. Once you know the given, table is probability distribution, how do you find the mean and variance for the random variable? This guy is random variable because x is variable. So the mean, they are asking you to find the mean, variance, and standard deviation for this distribution. For mean, you could use this formula. For the variance, you could use this formula. Then to find the standard deviation, remember, check your note, please. The standard deviation is simply the square root of variance. Once you know this variance answer, simply take the square root to find the, standard deviation. Okay, so let's do that then. Problem number 15. So I'm finding first mean, right? I'm using first formula, summation x times px. What does mean by that? This means take the first possible x value, multiply with its corresponding probability. In this problem, how many different x values? 1, 2, 3, 4, 5 different x values. So you have to add 5 times. First possible x value is 1 here, right? So 1 multiply with its probability is 0.27. This is 1. Summation means keep on adding. Now take the second value, which is 2, then multiply with its corresponding probability, which is 0.46, and so on. 3 times its probability is 0.21 plus 4 times its probability is 0.05 plus 5 times its probability is 0.01. So now take your calculator and simplify this. So if you do correctly, you could get 2.07. So that is the mean of the problem. Remember, mu means mean. Population mean, right? It is there. So now, once you know the mean answer, it is easy to find the variance. Variance of the distribution is, we use simply sigma squared, right? Remember, summation, this notation is uppercase sigma. This is lowercase sigma. It is a lowercase sigma. So this also we call as a sigma. Okay, lowercase. So how do you find the variance? Use this formula. Summation of value squared times its corresponding probability, add everything, then subtract mu squared. Mu means mean, right? Okay, if you do that, now you are taking the value but squaring that value, right? The first value is 1. So it is 1 squared times its probability. 0.27. Here you need to be very careful. You are squaring only the value, not the probability. Okay, only the value square, then times probability, plus second value squared, then times its probability, then third value square and its probability, plus 4 squared, then its probability 0.05, then plus 5 squared, its probability 0.01. Now take your calculator, add this all, then subtract the mu squared. Mu is 2.07, okay? But I need to square that as well. So now you could plugging everything into calculator and check. So if you do correctly, you should get 0.7651. That was the answer I got. Please correct me if I am not correct. So that is variance. Once you know variance, it is always easy to find standard deviation. Standard deviation is simply the square root of variance. Okay. That is square root of the variance answer. Just now I got 0.7651. Okay. Now if you simplify that, it is 0.8747. Okay. So this is the way to find the standard deviation. Okay. So we are in last problem. Last problem coming from 5.3, that is a binomial distribution. Okay, binomial distribution. So please go and refer your notes if you are not done so far. Binomial distribution means always when you perform an experiment, you are looking for only two possible things. One is either success, another one is maybe failure. So always you will have two outputs, right? Those kind of experiments are called binomial experiment. When you toss a coin, of course, we will have either heads or tails, right? Two possibilities. Suppose if you are looking for heads, you want to, you want to have, heads. That means once you get tails, then that is not, we wanted. So it's going to be considered like a failure, right? So in this problem, what's happening? We are tossing 10 coins, right, simultaneously. So each coin will give you either heads or tails, but we are counting how many heads we are getting. So our task is to get what? Heads, right? When you get heads, you succeed. If you are not getting heads, you got failure, right? So please go and refer your binomial distribution problem. The probability of success, the probability of success for a single trial, you had to assume that you are only performing one time, tossing one coin. Remember, so if you want to find that, the probability of success for a single trial, this is denoted by little p in our note, right? In this problem, you have to imagine you are tossing a coin just one time, or single coin, right? Then the probability of success is here what? Because we are looking for the number of heads. Once you have heads in your coin, you are succeeded. So that means the getting heads is half stands, right? Therefore, little p is half here. We have always one formula here. The probability of success plus the probability of failure we take as little q always add up to 1. In this case, we know that little p is half. That means q is automatically will be half, right? Success and failure has same chances, right? 50-50. So first of all, you need to identify p and q in the problem. Okay. Now you have the formula. That's it. Simply plugging the values. What is little n here? Little n is total number of trials you are doing. In this particular problem, we are tossing 10 coins. Therefore, n is 10 here. You are performing 10 trials in total. That's the meaning. So you have to find these numbers. That's it. Then plugging these values into your formula to find mean, standard deviation, and variance. Okay. So what is the formula for mean? Mean formula for the binomial experiment is simply n times p. We know now n is 10, p is 1/2. That is simplified, right? Then how do you find the variance? Variance formula says sigma squared is n times p times q. N is again 10. The probability of success is half. Probability of failure also half. So simplify this. That is going to be 2.5. Once you know variance, it is always easy to find the standard deviation. Simply square root of variance. So that is square root of 2.5. Okay. And it should be 1.258. Okay. So this is very, very easy problem, tossing a coin.